Hello and welcome back to another episode of Physics Partner. Today we are delving into the fascinating world of radar technology. From tracking aircraft to predicting weather patterns, radar plays a pivotal role in modern society. At its core, radar, an acronym for radio detection and ranging, leverages the principles of electromagnetic waves to detect and locate objects. When radar emits radio waves, these waves travel at the speed of light, interacting with various surfaces in their path. Upon striking an object such as an aircraft or a rain cloud, the wave reflects back to the radar receiver. The time it takes for these waves to return enables engineers to calculate the distance of the object with remarkable accuracy. The Doppler effect further enriches radar's capability by allowing it to measure not only position but also the speed of moving objects. As the frequency of the reflected wave changes based on a relative motion, radar system can determine whether an object is approaching or receding with incredible precision. This fundamental property is the cornerstone of advanced radar applications. Let's dive into the operational mechanics. A radar system consists of a transmitter that emits radio waves, an antenna that directs these pulses, and a receiver that processes the reflected waves. The integration of digital signal processing ensures that the radar can differentiate between multiple targets, filter out noise, and enhance the clarity of data it receives. Modern radar systems utilize frequency modulated continuous wave, in short FMCW technology, enabling constant transmission of waves while continuously analyzing the return signals. This constant oscillation boosts resolution and enhances range, making radar systems exceptionally versatile. Radar technology is indispensable across myriad fields. In aviation, it provides crucial information for air traffic control, ensuring the safe navigation of commercial flights. In meteorology, radar systems facilitate real-time weather tracking, helping forecasters predict storms and severe weather events. Militarily, radar serves as a formidable defense tool, detecting enemy aircraft and missiles, shaping strategic operations around the globe. As we venture into the cutting-edge realm of radar, one standout is the ANPY6 radar system, utilized by the US Navy, boasting an extraordinary range and target discrimination. It harnesses an array of gallium nitride (GaN) technology to provide continuous 360-degree coverage. This revolutionary system represents the pinnacle of radar technology, effectively streamlining naval operations and enhancing maritime security. In conclusion, the journey of radar technology from its inception to today's advanced systems is nothing short of extraordinary. Its profound impact on various industries underscores our reliance on this remarkable invention. So I think it's enough for today. So thank you very much for listening and watching. I hope you enjoyed the video. I hope this video is useful for you. So take care of yourself and don't hesitate to write an email if you have any question, query, suggestion, and even classes are required. Take care of yourself meanwhile. See you in the next video. Goodbye.